Good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by SimGrep. My name is Cody, and I'd love to welcome you back to Techstrong Learning, where we have an exciting presentation ahead. Before we get that ball rolling, I do want to cover just a couple of housekeeping notes for you. First of all, we are recording today's session. So if you'd like to rewatch at a later point in time, or of course, if you'd like to share with your team, you will be receiving an email with a link to access the recording on demand. You will receive that shortly after we conclude this live session today, so you will not be waiting too long. If you'd like to engage with us, there are a couple of ways to do so. The first option is the chat tab, which can be found on the right side of your screen. So if you see that chat tab, I'd like you to go ahead and test it out for us by letting us know from where in the world you are joining us. Now, right next to that chat tab on the right side, you'll find a Q&A tab, and we want you to use that Q&A tab for any questions that you might have for us. So be sure to send your questions into that Q&A. We'll try to answer a couple as we go throughout our program today, but we do have plenty of time set aside at the end to have a formal Q&A session. Of course, before we close things out today, I am going to be giving away 4 $25 Amazon gift cards. So be sure to stick around for the entire duration of our program to see if you're one of our lucky winners. Our topic today is overcoming supply chain security alert fatigue. And I'm joined today by Adam Berman, head of SimGrep supply chain at SimGrep. So Adam, thank you so much for joining us today on Techstrong Learning. I'm going to pass the virtual baton over to you and let you run away with it.
Well, thanks, Cody. Glad to be here. As you said, my name is Adam. I'm the head of SimGrep supply chain. And I'm talking about a topic today that I'm really excited and interested in and been deep diving on for a long time, which is vulnerability management and overcoming the inundation of noisy supply chain security alerts. I was recently told by a new colleague of mine, Tanya from She Hacks Purple, that she also wrote a blog post about entitled "When is a vulnerability not a vulnerability?" So this is not a new topic, but hopefully we can tackle this in interesting and new ways and learn some lessons about how we can better scale our supply chain and SCA programs. First, a little bit about me. My name is Adam Berman. As I said, I'm the head of SimGrep supply chain. I lead our engineering and product teams there. I started at SimGrep about 2.5 years ago as a staff engineer, and I've had the pleasure of getting to build security tools, many of which are open source. I work at SimGrep, and we build the open source static analysis tool. In this talk, we're going to talk about vulnerability management. So who has ever opened up their code base or security tool and seen a tab with a big alert that looks something like this? A huge number of vulnerabilities. But the reality is, if this were really true, if all of these vulnerabilities were real and dangerous in our apps, we'd probably all be fired, right? But we all know that number isn't real. So many of those alerts are just not a real risk. The trick is finding those real dangerous needles in the haystack. And the real trick is finding those needles without having to overwhelm your team with a huge, huge quantity of work. So in this talk, we're going to start from the beginning and cover the rise of open source software usage and its impact on AppSec teams. We'll dive into how traditional SCA tools work and try to solve this problem. We'll then really hit the problem that many of us are familiar with, the challenge of running an effective and efficient SCA program. And then we'll dig into why reachability analysis helps an AppSec team scale their SCA programs. Hopefully, by the end of this talk, we can get to some strategies for feeling like, well, not quite ignoring alerts, but reducing noisy alerts. So let's start with the rise of open source software, kind of a trade-off between velocity and risk. Open source software usage has massively increased. When I started writing code a long time ago, open source software was used, but today, even a small project has thousands of dependencies. In SimGrep Cloud, our cloud application, over 99% of the lines of code come from open source dependencies. And we're a small or medium-sized company. Our front end is just not that complex, but our yarn.lockfile is 30,000 lines long. But this is good. these open source projects are solving problems that are generic to all of us. I don't have to spend time on figuring out how to render HTML or parse a cookie. I use React and Flask and a bunch of other open source projects that implement that functionality really well. I could spend more of my engineering time on business problems that are unique to my business. But the downside is that I inherit all the security problems of the open source projects I depend on. And old vulnerabilities live forever. They're still out there, and hackers keep blasting the internet, seeing if anyone is using the vulnerable versions. These are from our logs a while back, catching some of this spam. This is especially funny to us since we don't use any WordPress at all, but people are still attacking our surface to see if there's any old WordPress versions out there that are vulnerable to this particular attack. And looking at the rate of vulnerability disclosure for open source projects, it just keeps on going up. We see 8,000 new vulnerabilities disclosed in the last few months, a trend that just keeps on continuing to go up and up and up. And if these vulnerabilities live forever, it means that we just see a just huge problem that we have to solve. And that doesn't even take into account folks who are running microservices or projects with multiple lock files. Think about how many services your teams are supporting. Think about how many alerts you get when disclosures happen on your support week. A single unique disclosure could account for tens or hundreds of vulnerabilities across a large number of projects. And then someone, often the security team, has to understand the context of each application and how they use that tool, that open source project with the vulnerability in order to figure out how to triage that vulnerability. The worst part about this is that a huge percentage of these vulnerabilities are false positives. We ran a study of 1,100 of the most popular open source packages with vulnerabilities. Our analysis showed that about 2% of reported vulnerabilities are even theoretically reachable, never mind exploitable. We've replicated these results on customer code and enterprise environments as well. And this means it's a little bit of evidence for, I feel like, what we all know in our gut, that SEA programs are typically pretty low ROI. Okay, but before we dive into how to fix this, we need to back up a little bit and figure out how did we end up in this world? So let's dive into the traditional approach to SEA. There are a bunch of free tools like OAuth's Dependency Track and Dependabot. There are paid solutions like Black Duck and Sneak, but fundamentally these tools are pretty similar when it comes to vulnerability management. They collect a database of vulnerabilities. These are sourced from public vulnerability databases like NVD, or perhaps they have their own security research team investigating packages and finding vulnerabilities. And each database entry looks something like this: a package, a vulnerable version or range, the minimum patched version. Ideally, they'll also be accompanied by helpful information like what we see here: a description, a recommendation, a severity. And then they have some ability to scan your dependencies. Perhaps they scan your manifest file or your lock files. Maybe they query the build system for a list, but in some way they get your list of dependencies. And finally, they match the package versions that you have in your system to that database, and they tell you if you have a vulnerable package and which vulnerable packages you have. So you end up with a list like this of vulnerable packages in your ecosystem. So what's the issue here? The problem is that this is not a list of vulnerabilities that are exposed in your system. Instead, it's a list of packages that have vulnerabilities in your system. The vast majority of packages that might show up on this list are not dangerous based on how they're being used in the applications. For a package to be dangerous, the first-party code must use the vulnerable part of the library. So let's take this Lodash vulnerability as an example. So what is Lodash? It's a JavaScript utility library with, as you can see, a few hundred public functions on it. The vulnerability here says that merge with one specific function is vulnerable to a prototype pollution vulnerability. But the whole library isn't vulnerable at this version. Just this function and a few more that also have disclosures associated with them, like merge and merge deep. If, say, I use Lodash's partition method to manipulate an array, I'm totally safe. Partition is not vulnerable, and it does not rely on any of the vulnerable methods. There's no undue risk added to my application. Now, looking back at this list, you might be thinking, why not just fix them all anyway? And if there are 5, that might be relatively easy. We all want to live in a world where all vulnerabilities are fixed, but many of us work at companies or organizations where getting to inbox 0 is just not feasible. Instead, we're closer to here, a huge or potentially untold number of vulnerabilities to triage. Why is it so tough to get to inbox 0? Well, in reality, upgrading is rarely quite that simple. Organizations usually are not only one version behind. When a vulnerability is disclosed or being addressed, we might be dozens of versions behind the closest safe version. In the best case scenario, where you have a rock solid test suite, you still need the developer bandwidth to fix the upgrades that have breaking changes. And then without a really good test suite, you also have to do the manual work to figure out if the changes were breaking in the first place. And you might need to land a fix for each vulnerability across a breadth of services at your organization. And developers have a lot of different concerns. Building features, scaling existing features, paying down tech debt, fixing bugs, scoping out new work, upgrades and other security work have to be balanced against all of these competing needs. So there's a really tough trade-off here. Security teams face similar time constraints with asks from across the business. Prioritizing triage takes time away from other important work. And since vulnerabilities just keep on getting disclosed, this is a forever commitment. So security teams are often faced with a really extremely difficult choice, balancing the value of the program against the resources required for an SCA program in a resource-constrained environment. For some, running a security-focused SCA program just isn't really worth it. It's too much work for too little reward, and instead the goal becomes meeting the minimum bar for compliance. Folks might turn on a tool that can check the compliance box, ignore the rest of the results, and accept the risk. For others, they simply cannot accept the risk. The needle in the haystack is too dangerous. So folks commit to the toil of manually triaging these alerts so they can find the very few vulnerabilities to forward to their engineering counterparts and to fix together. But this is a terrible choice. Reachability, leveraged properly, helps security teams move beyond that choice by introducing leverage. Reachability analysis helps security teams run a more scalable, pragmatic SCA program. It lets us ignore or deprioritize less urgent vulnerabilities in the ever-growing stack of priorities. It lets us find and immediately address the vulnerabilities that are the most pressing today so we can be strategic with our triage time. And it lets us codify acceptable and unacceptable use of packages with known vulnerabilities so that the developers can fix their own code and prevent real security issues before code is merged in. Okay, so what is reachability analysis and how does it work? Reachability analysis is a process by which we check to see if the vulnerable part of the library is used. We call it reachable when the dangerous part of a vulnerable package is used by the first-party code. Let's go over an example. Here we import Lodash. Let's say it's at a vulnerable version. We see on line 5 here evidence of reachability. We see that the program has called the dangerous function on the library with untrusted user input. And then on line 8, we see how a user might be able to get malicious input into the vulnerable function. Here we see a very similar function. Same user input, same library, but we're calling the zip function, which we know not to be vulnerable. Thus, we'd call the vulnerability in this context unreachable. I want to make an important distinction here. This is different from exploitability. A vulnerability might be reachable, but still not exploitable. Exploitability requires a lot more context: the environment, the infrastructure, the ability to create a payload that exercises everything properly. Most techniques for exploitability analysis lean more towards false positives. Reachability analysis more towards false negatives. Reachability analysis may still have false positives. They may not all be exploitable, but you are more likely to catch everything. Let's go back to the previous example. From this code sample, we simply cannot tell if the script is exploitable. We would need to know how it's being used. Is it in a customer-facing environment? Is whatever process.argv, if whatever gets passed in via process.argv something that customers or untrusted data could manipulate? Or is it only used by developers passing in commands that they know to be safe? Again, reachability analysis here is a lower bar. Basically, does the code touch the vulnerable part of the library? So let's talk about the components of reachability analysis and how to do it. Reachability analysis has three parts. The first, you need an engine of some kind that can scan code and detect some kind of pattern in the code. A nice property of reachability analysis is that it can be done with static analysis. We don't need to compile the code or test it dynamically. At SemGrep, we build and maintain an open source static analysis tool, SemGrep, which works really well for analysis like this. And I'll share some examples of how we use it in a bit. But on the lightweight side, you might use something as simple as grep. You might use a language-specific linter like Rubocop or ESLint for something like this as well, if you already have that built into your toolchain. Second, you need an engine that can tell what version of a library is being used in an application. Again, SemGrep can do this, but there are also a lot of great tools out there as well. Dependency Track is another open source tool that you can use for this. Finally, you need a database of vulnerabilities, and you need to know the list of vulnerable functions for a library at a particular version and under what conditions they are dangerous. There's no silver bullet here. This is going to require a little bit of work and a decent amount of security knowledge. But essentially, you flip the script on triaging a vulnerability. It means rather than digging into your own code to see how you use the library, you're digging into the vulnerable library, looking at the patch diff, reading blog posts on successful exploits, etc., to figure out how it could potentially be dangerous. We've also found that some open source databases have some lists of vulnerable functions, and there's an effort in the open source community through tools like OSV and others to try to provide that information more readily. Okay, so let's look at an example of what this looks like in the real world. So towards the end of 2022, we saw a disclosure in the PyTorch library. Looking at the issue on the library itself, it doesn't take too long to figure out what's dangerous about the library. Someone even did a great job of demonstrating the exploit on the ticket itself in GitHub. So the first part, we need to specify that this is for Python. We need to write a message. We need to specify the pattern. So here's what it looks like to implement something that scans your code to see that it's useful. The message here is important. Eventually, this message is going to populate to other people on the security team or developers. And so a high quality message here helps them be able to understand what to do, why this is important, and how to solve the problem. And then the pattern here, this is a SemGrep pattern, but this can be done in something like grep as well. You're looking for the usage of the vulnerable function. The second part of reachability analysis is the engine matching against the dependency version. Again, this is with the SemGrep syntax, but this is not a difficult thing to implement. We're looking for are you using the version of PyTorch below a particular version, 1.13.0 in this case. Now we can run this rule against a code base to see if it's used at all, and then if the usage is reachable or unreachable. Okay, so now that we have some rules, let's talk about how we build reachability into our SCA program. To do this, let's zoom out and think about how vulnerabilities might show up in our systems in the first place. So there are two main vectors of vulnerability risks: new disclosures and new commits. The first is a new disclosure. New disclosures will impact old code, code that hasn't been touched in years, code that you really thought was safe. But now it turns out that Nokigiri XML. Apologies, I think I had an audio issue. Cool, okay, I think it's back. So the first is a new disclosure. New disclosures impact old code, code that hasn't been touched in years, code that you really thought was safe. But now it turns out that Nokigiri XML parser wasn't safe after all, and we either need to spend some time sanitizing the input or we need to upgrade. To do reachability analysis here, you want to be able to run scans at request time. For this, you might run a script that pulls your repos and scans the whole repo with your new rule. If you use a solid static analysis tool, these scans are typically dominated by how long it takes to pull the code rather than the scans themselves. So some folks have nightly or hourly cron scans pre-scheduled in CI so that you can check in your rule and it will auto-scan the whole repo. But to get ahead of this kind of problem, you have to scan the whole repo, not just new code, because you're trying to scan if all of your old code has newly been impacted by this new disclosure. The second vector here is new or changed code. You've scanned and confirmed that at the time of the disclosure, the vulnerability didn't exist in your code base. But if only people would stop changing the code. Someone might check in a new library that has a vulnerability in it, or else they might use the reachable function for the very first time on an existing vulnerable but previously unreachable library. So we need to put a guardrail in place to prevent developers from introducing new vulnerabilities. To prevent these threats, folks instrument PR scans to make sure that the code change doesn't let in any newly reachable vulnerabilities. This is ideal because it lets developers self-serve the fix, and you can make it blocking to ensure that the vulnerability never makes it into production. For some orgs, PR comments or blocking PRs may not be feasible. In that case, you can orchestrate out of band scans that can allow the security or developer teams to fast follow with the fix without slowing down development velocity. So to run a program like this for yourself, here's what it looks like in action. First, you hook up a feed to some vulnerability database so that you get notified when new vulnerabilities are disclosed. Many folks may already have something like this in place. Second, when a vulnerability comes through, rather than jumping into your code to triage, you dig into the vulnerability itself. Is there a single function that is vulnerable? With what kinds of inputs are they vulnerable? Is it only conditionally problematic or vulnerable? Then you write the rule and you scan your existing code base to see if you're impacted. Finally, you check it in as a guardrail to make sure that you don't run into this vulnerability in the future. By implementing a reachability analysis program, your AppSec team gets to move a level up from manual toil to automating away current and future work. Again, this is by no means a silver bullet. Static analysis is imperfect. There are both false positives and false negatives, as with any analysis technique. But our goal here is to run a pragmatic security program. There are some vulnerabilities that are so bad, you may want to excise them basically no matter what. I'm looking at you, Log4j. But reachability can still be helpful in those cases because it can help you figure out what to prioritize in the event of the incident response. Where are you most likely to get hit are areas in the code where you can see that you're using the vulnerable function. It's also not a trivial amount of work researching and writing rules for your reachability program. But especially for orgs with multiple services and multiple applications, this lets you scale a single research effort rather than having to manually triage each vulnerability instance for each service by hand. If you don't want to run this program yourself, there are products out there that do this. I work at SemGrep. We do this with SemGrep Supply Chain, but there exists a variety of SCA tools that do some sort of program like this. And build versus buy is something every org must decide for themselves. Long term, I hope all SCA tools, both commercial and open source, move toward reachability analysis. Security isn't and shouldn't be a purity test. And here at SemGrep, we believe in pragmatic security, and pragmatic security should not require so much toil. Cool. Well, that's it for my talk. I'll stop sharing and see if there's any questions from the audience.
Yeah, hey, Adam, we've got a couple questions that have come in, so we'll just take them from the earliest. Could you share examples of common challenges that contribute to supply chain security alert fatigue? And what strategies can organizations employ to address those challenges?
Yeah, I think that's a great question. I think the challenge here comes from, unreasonable expectations around what security teams must be responsible for and how the organization must work. If the expectation is that no vulnerability should ever exist in the code, or that all packages should be constantly updated, it can be very difficult to move yourself to that world. And you could be asking your teams to prioritize this over the value that it really represents. I think the teams that have dealt with this the best are able to have nuanced conversations, both internally within the security org and externally with the security partners, both like on the executive side with the development teams, to be able to decide on a case-by-case basis where to really invest time in upgrades and where it's okay to deprioritize. I think it's fair to say that like someone has to look at these alerts, but I think it's unfair to say every one of these alerts needs to have a manual intervention, needs hours or days of work. So the goal is to find that like happy medium. And tools like techniques like reachability analysis can really help take away a lot of that triage and help you focus on the few alerts that you really do want to prioritize.
Awesome. Awesome. Thank you, Adam. Does SimGrep's reachability analysis extend to transitive dependencies? And if so, how many levels deep?
Yeah, right now we don't do transitive reachability directly with SimGrep, and any of these tools we talked about today would be looking at directly at the packages and the code, how your code uses those packages. But I think there's a few pieces of this that are important to talk about. One is that many vulnerabilities will bubble up as CVEs on the parent package. So if a CVE disclosure happens on one package and it is exploitable and causes a real vulnerability on a package that uses it, that will often create a CVE on the parent package itself, at which point a static analysis tool can then check to see, are you using the parent library and how are you using the parent library? So that's one piece to take into account. And then the second piece to take into account is just how difficult it is to exploit a vulnerability deep in the transitive dependency tree. Every level of indirection means a level of indirection that a attack has to be able to overcome. That means often they'd have to chain together multiple attacks or multiple, really understand how the code is being used many layers deep to be able to figure out a way to get the exploits, to get the malicious into the transitive dependency. And so it really makes it like a much more complicated attack vector. We already see that only 2% of vulnerabilities are reachable at the direct layer. So as we start to look at indirect dependencies and transitive dependencies, every layer deeper you go, the less likely it is to be potentially unreachable. You're already at 0.04%. The next layer down, and then as you keep on going layer down, you can multiply it out yourself. The chances become very, very, very low.
Gotcha. Yep, that all makes sense. So if the vulnerable function is used, but the inputs are static or not from user input, generally, is it considered to be reachable?
Yeah, I think this is a question for your own organization. This is always going to be a trade-off between precision versus recall. And when we're doing this at SemGrep, we really kind of favor the side of recall because you're already getting such a precision benefit. So let me back up a second too. It's what we're trying to balance against is false positives versus false negatives. And let's say we were going to say one technique would add one more false positive and one technique would add one more false negative. For us in our internal calculation, we want to really prevent that one false negative, because a false negative telling you that something is unreachable when it really was reachable and even exploitable, that is that's bad. We're going to end up in a lot of trouble. You're going to end up in a lot of trouble. But what we found is that even with pretty sensitive rules for reachability that don't go from source to sink looking for true, does the user data make it all the way into the vulnerable sink, just looking for is the vulnerable functionality used at all, we're able to reduce the number of false positives by such a huge percentage without introducing a lot of false negatives, that the trade-off for few more isn't worth it. So the 2% number we referenced earlier for, if you're talking about going from 1,000 to 20 vulnerabilities that are reachable, it still might be true that 10 of those are false positives because there isn't user input, dynamic user input, the untrusted user input that makes its way into the vulnerable sink. But we still think that that trade-off is worthwhile because, again, you're only dealing with 10 false positives instead of 990 false positives.
Gotcha. And so as a follow-up to that a little bit, this same participant would like to hear more on how we detect whether input is potentially user input.
Yeah, that's a good question. I think this is hard to know in abstract generally. When we're thinking about building rules for our own code base, we know our APIs pretty well, and we can write patterns for the patterns we expect to exist in code. So for us, we run a Flask app. We're looking at our handlers in the Flask app to understand where inputs come in. We're looking at our the protobufs that we define as our schema between our front end and our back end to understand the contract that we make there. And then we're trying to decide, okay, if we're looking from source to sink, what kind of user input can get in there. But it's not enough to just look at the inputs from the APIs. You have to think about how your APIs might interact with the database. Is it possible for untrusted input to live in the database without being sanitized? If so, you got to then look at think of your database as another place where untrusted input can make its way in. So you're thinking about the code base you have, and then kind of the various different entry and exit points through which data can make its way in. Do you interact with third-party connectors? Those could have untrusted data that comes in. So it's trying to look in those directions as well.
Awesome, thank you for that. And to participant 80 who asked those two questions, if you do have any more follow-ups, let us know.
Yep.
So moving right on into our next one, Adam, where do you see this work best centralized? Would this be done in the development organizations or in the AppSec security team? Any thoughts?
Yeah, I think for this specific piece, you want to develop it as a partnership. If it's just the AppSec team in isolation, these kinds of AppSec code security programs done in isolation don't tend to get a lot of traction. Bring in your developers as partners, even just in terms of education, in terms of building a security champions programs that people on different teams are aware of them, that they know that they have the ability to report false positives and give you feedback on the rules that you're writing. You want to build that virtuous cycle with developer teams so that they know that the door is open, so they know this is a partnership, so that they know the goal of this is that they have to spend less time on things that aren't as important. But you might find that your AppSec team is the one running the program itself. That someone needs to be writing those rules. And this is again going to be kind of a nuanced question of who in your organization is best set up to do this. It may be that your teams use such diverse technical tools that you may need the teams to be responsible for writing your reachability analysis rules, or you may need to outsource that somehow. In that case, that partnership is going to be really mission critical because you're going to rely on developers to not just handle the items that are reachable, but when disclosures come through, to do some of that reachability analysis or help you write the rules yourselves. We find that one of the helpful ways to do this is to treat the tooling itself for PR comments, the tooling itself for running these scans, to make that sort of agnostic to engineering or security, because developers want similar code review functionality. So if you have tooling that can be used so that developers can write their own rules to make it, they never have to check double equals or triple equals in JavaScript again, never have to check is versus equals in Python again, be able to augment some of their own best practices, make sure routes are authenticated, that they're using the best practices they want to see in their organizations, that those tools will have much higher adoption because the developers will be familiar with them, they'll see the value of them in their own sense, and they'll understand why the security team is plugging into them as well.
Awesome, Adam. Thanks so much for that in-depth answer. At this point in time, I'm not seeing any more questions, so I do just want to pitch to our audience. If you have any more questions, do send them in. We do still have a few more minutes here. Adam, in the meantime, I'm going to give away some gift cards.
Sure.
And while I do that, I do also just want to let you know, I'm going to come back to you asking you what your parting words might be. So just think on that for just a second here. So in the chat, everyone, I have uploaded a link to fill out our survey. It's also pinned to the top of the chat. Do please click that before we close out today, because we'd love to hear your feedback about our program. Or, of course, if you have any suggestions for future programs, send those in there as well. We would love to hear from you. Additionally, the 4 winners of our $25 Amazon gift card drawing, they are Vicky E, Ethan F, Jen S, and Spike R. So to our 4 winners, congratulations. Keep an eye on your inbox to claim your gift card. We'll reach out to you in the next 48 hours. If you don't happen to see an email from us, check your spam folder just in case it happens to get filtered out. All right, Adam, it looks like you have gone so in depth that we have no more questions from our audience. So like I said, I want to pitch it back on over to you for any closing words you might have.
Yeah, thanks. I think here at SumGroup, we really care about pragmatic and like useful security. We try to push people to avoid the security theater and focus on what's really going to make an impact to your organization. So the last thing I'll end on here, I guess, is that security is really nuanced, and having these sorts of blanket rules makes it tough to really be able to do our jobs well. So we really encourage like partnerships, nuanced conversations, communicating well, and tools like and techniques like reachability analysis can help be those centerpieces to allow you to kind of operationalize that nuance as well. As an aside, SemGrep is an open source tool. If you have a community, come join us at semgrep.slack.com. So you can check out and join the community and talk to other people who are using the tool. Yeah, we're excited to keep the conversation going.
Awesome. Well, Adam, if you have any links to that Slack, go ahead and throw that in the chat real quick. That way, anyone who is interested can quickly grab that before we close things out. It looks like we did get a couple questions, and they are just about, is this recorded? And yes, this session was being recorded. So you will be sent an email with a link to access the recording on demand so that you can rewatch, you can share, you can have it at your disposal. I'd like to thank SemGrip for sponsoring our program today and just making sure I've covered all of our bases. Adam, thank you so much for joining us. I appreciate you throwing that link in the chat there, and I'll make sure that gets converted into our on-demand handouts as well. But Adam, thanks so much for joining us. This was such an awesome session.
Yeah, thanks, Cody, and thanks everyone for joining us.
Of course, everyone, thank you so much for sticking around. Once again, there's that survey there, but we do hope to see everyone at a future Techstrong Learning experience. Have a great rest of your day, and you may now disconnect. Thanks again, Adam.